Well, hello there. Good to see you back. We got a new fun topic that's going to save us a lot of time compared to yesterday because how annoying was it to find all three angles and all three sides? And I'm sure some of us were like, well, back in the day, we just used maybe three sides in an angle or two sides in an angle. So today, one of our goals is to see what's the smallest amount of stuff we can have to say that two triangles are similar. Maybe rather than having all six things, maybe I'll only have three things. Maybe I'll only have two things. Wouldn't that be awesome? So to start this off, we're going to have some pretty difficult proofs today. Not necessarily difficult proofs, but some difficult algebra to show these theorems. But they're really, really cool after we get to them. The first thing I want you to do is actually fill in this triangle. This is a 2x topic. Is that I want you to find the length of little a here, and then I want you to find big B. So take your time, maybe stop the video at this point, find what little a is and what big B is. To help you out, I'm going to give you the law of cosines. And to find big B, once you have a, you're going to use the law of sines. So again, stop the video real quick and find those two lengths. I want to see your work in both of these to get those two lengths. So hopefully you started it up again. If if you did this correctly, you should get 6 root 7. Simplify your radical if you got the square root of 252. Maybe just simplify that a little further. And then angle B should be approximately 79 degrees. That's probably the most approximate I'll get. Usually I'll go to 2 decimals, but for now, just for ease, we're going to say that's 79. If we wanted to, we could find C as 41. Now, why we did this is maybe I want to find a triangle that's similar to this triangle ABC. If that were the case, the corresponding angles would have to be the same. But then there'd have to be some K factor with this A, B, and C. And that's what we're going to actually do to prove one of our theorems. Notice at the beginning they gave me a side, an angle, and a side. So maybe if they give me a side, an angle, a side, I can find all the rest of the stuff to say that it has a common proportion. And that's what's going to happen here. And I'm going to try and walk you through this as best I can with these steps. I want you to set up the law of cosines with these variables. Instead of a, b, and c, x, y, and z. So just like we had a squared, it's going to be little x squared equals y squared plus z squared minus 2yz, and then the cosine of big X. Now what I want you to do, and I want you to do in your homework, is plug the equivalent variables in with the k's. So instead of k, or as y is going to be kb, but we know what b is. So for example, I'm looking for x squared, and I'm eventually going to want to find x. Instead of a y, I'm going to put 18k squared. And then what I want you to do is put plus, and then fill in your 12k squared minus 2 times 18k, so on and so forth. Okay, you're going to get this big long equation. Then what I want you to do is simplify it. You can simplify 18k squared, and you're going to get a bunch of k squareds and simplify that. And eventually, I just want you to see x equals blah, 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 blah. Now, let's think about what would happen if we did this correctly. If this is C, this side should be KC. If this is B, this should be KB. Now, if this is my A, it should look like X equals K times A. Now, we found A over here to be 6 root 7. So when you simplify this, your goal should be X is equal to 6 root 7 times K. See if you can get to that. That's the work I'm going to be looking for. Okay? Once you have that, then I want you to find big Y. Now you're going to have to use the law of sines for that. So it's going to say the sine of Y, I don't know it, over KB, which we know KB is 18K, equals the sine of, I know X, so sine of 60 over, I know I know X now is 6 root 7 K. So simplify this, do your algebra cross multiplication to see if you can find y, and see if there is any relationship to the previous triangle. What we're trying to show here is that if I'm given two sides and the angle that is included or in between them, I can find everything else. What I mean by that is the third side has the same scale factor as the other two sides, and the two corresponding angles are actually the same as the original. So once you go through this, you've actually proved one of our first similarity theorems we're going to have of side angle side. We can guarantee these triangles are similar. So if I'm given two sides, let's say I'm given A and B, and the angle inside of them, doesn't matter how big it is, but it's got to be in between the two sides. And I'm given another triangle that I find has the same scale factor, and then the angle in between them is the same, then these two triangles are actually similar. So maybe let's call this CBA, and we'll call this DEF. We could write a similarity statement. Now our similarity statement is going to be a little different now. Before we were just naming the triangles. So for example, I would say triangle ABC is similar to triangle. Well, I can't just go DEF again. Again, I want to go, I have no angle with this. I go to the side I know nothing about, F to E. Then notice from B to C, I went down to A. Well, I got to go to the side with the same scale factor with A, E to D. Now, that used to be our similarity statement, but now we're going to add our similarity theorem. I would say triangle ABC is similar to triangle FED by the side angle side similarity theorem. We've actually made a theorem for this because no matter what AB is in that angle, we can find the rest of the stuff and say those are similar. Okay, so that's our first one. That's our first similarity statement, side angle side. Then we go to this problem. Okay, I want you to write an equation for the cosine of A. Now we usually have A squared equals B squared plus C squared minus 2BC cosine of A. I want you to rearrange this algebraically to get an equation for the cosine of A. Try that real quick. I want to see your algebraic work to get to the end. Maybe stop the video now so you can do that. Hopefully you should have gotten A squared minus B squared minus C squared all over negative 2BC, and that is the cosine of A. Also, it's a negative 2 on the bottom. So, now they gave me three sides. If they give me three sides, I better make sure that the three angles that correspond are also congruent and the three sides have a common scale factor. So here's our setup. I notice that Z equals KC, X equals KA, and Y equals KB if it were similar. Now let's write the cosine of X. Well, over here we said the cosine of A, okay, it's going to be X squared minus Y squared minus Z squared all over negative 2YZ. I have my lead letter, and then I subtract the leftovers over negative 2 times the leftovers. Now, same thing as you did in the first one. Fill in the variables with the k's now. So it's going to look like the cosine of big X equals X, KA squared, so KA squared, minus Y is KB squared, minus Z is a KC squared, all over negative 2 times KB, KC. Then I want you to simplify that. If you do it correctly, it's going to look kind of familiar. If it looks kind of familiar, and if you get the same equation, no matter what A, B, and C are, that means A is going to equal X. That's what we want to have happen, that if I give them three sides, I know that the corresponding angles are congruent. So I want to see a simplified equation for the cosine of X, and it should kind of look pretty familiar. Hint, hint, hint. If you do find it, great job, and you have proven our next case of side, side, side. If we're given three sides, A, B, C, which means it's A, B, C, or D, E, F. I'm going to switch it up on you. Maybe this is KA, this is KB, this is KC. So then, that's a triangle. A, B, C is similar to triangle. What do you think it is? A, B, C. I'm sorry, A, B, C. Well, that means I went C side, the A side, and the B side. So I go C side, A side, B side, DEF by the side similarity theorem. Okay? Lastly, what I want you to try is this proof. Oops, excuse me. I'll go split screen here. This proof is in your book if you want to look from there on page 171. But what I want you to do is go through this proof and try and put reasons to the proof. Now, right off the bat, look what they gave you. All they've given you is two angles. That's it. Just two angles are congruent, two sets of angles are congruent, and we want to know or prove if these triangles can actually be similar, just knowing two angles. So they walk you through it, they give you the step-by-step, but what I want you to do is just put some reasons in for 1 through 8, and that's what I'll be checking tomorrow. Hopefully you get through it, and what you'll actually find, and you can kind of see at the end, at the bottom there, it does prove angle, angle. Just by knowing two angles, this is awesome. I don't care where the angles are, as long as I have two sets of corresponding angles, ABC, DEF. If A matches with D and B matches with E, these are similar. Triangle CBA is similar to triangle. Well, I named it differently, so I got to go FED by the angle similarity theorem. Be very precise. Write that similarity theorem each time because we are going to have some congruencies. So we have 3 similarities, or similarity theorems. We're going to have 4 in a second. That'll be in a later video. But for right now, side, 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 and angle, angle. Okay, here's part of your extra homework for tonight. Here's a homework challenge question. In a statement reason proof, using your givens, I'm giving you that M is parallel to N. I want you to prove to me these triangles are similar. If so, at the end, write your similarity statement. Make sure it's in that statement reason form. The second one, or the last one, is a homework challenge like we had last night. I'm giving you A, B, B, C, and CA, X, Y, Y, Z, and ZX. Are these two triangles similar? This one you don't have to prove, but I do want to see a similarity statement. Draw these triangles out, match which sides. If you're going to use side angle side, for example, I got to see that this has the same scale factor. If it's 2 to 4 and then 4 to 8, I got to see that somewhere on your paper. I want to see the matched side lengths. If it's an angle, just make sure you have that corresponding angle as included or in between your two sides. All right, so there's your 2 homework problems. There were a couple before with those proofs. Again, have fun. I know these proofs are new to you, but they're awesome. They're going to give you a really good look into the similarity of these triangles. Have fun tonight, and I'll see you tomorrow.